Hi friends, Mrs. McBride here. I hope everybody had a wonderful weekend. It was nice to actually enjoy some warm weather. As you can see, Kiwi and Gritty are completely passed out at the McBride house. We went to the driving range and did a little golfing and baked some cookies. So everybody is happy. Hopefully you guys are happy and doing well. Quick joke for you. Why are omelets so out of shape? They don't get enough exercise. Okay, so the idea here is we're talking about something called electromagnetic induction. So we've already seen that you can take a current and produce a magnetic field. Perhaps you missed this sweet demonstration. Okay, so that's where we took current and we saw that there was a magnetic field. Well, there was a gentleman by the name of Michael Faraday, pretty darn famous American scientist, who said, what if you have a magnetic field, can you produce current? Okay, so what I would like to do here is show you some stuff. So here we go. All right, so he says, what happens if you take this bar magnet and you have just a light bulb connected to a coil of wire, okay? And what he noticed is if you bring this in and out of the coil of wire, you'll get this light bulb to light. Pretty neat, huh? Okay, this is called electromagnetic induction because you are inducing a current that runs through the light bulb. Now, I could show you this a different way. This is something called a galvanometer, and it sort of measures the change in voltage. And you'll see that when I go through one direction, it goes to the negative, and when I go through the other direction, it sort of goes to the positive, okay? So if I were to keep moving this back and forth, you would see this constant change. Okay, well then Faraday was like, whoa, that's really cool. How could I make this have more current? So what he thought was, well, let's put 2 loops of wire. Okay, that's more. Okay, what if we put 3 loops of wire? Much better. Okay, so when you see a real electromagnet, what you're really seeing is lots and lots of coils of wire, okay, with current running through them that create a magnet. So sort of like the exact opposite of what's happening here. But again, you can see how the more loops you have, the more current is generated. And that's really important. And the other thing I want to show you here is you see how these are really small loops? We can also change those loops to be much larger in area. And we should see that when they have a larger area, it's also going to produce more current. Now, I want to show you these things because I know you're surprised, but there's equations that sort of relate to these things. Now, this is a FET simulation, so if you want, Google FET generator and you can play along yourself. Now, why is this important? Well, this is important because this is actually how we generate power. So in this case, I'm going to turn on the faucet. Okay, and it's turning a water wheel, and on that wheel is attached a bar magnet. Okay, and you can see that just in the same way, by the movement of the magnet, we're generating power, or we've got this electricity. Now, there's a bunch of different ways we could do better, right? Well, what happens if I turn the water up full strength, like you can imagine, would be at the hydroelectric power plant in, let's say, for example, Niagara Falls. Okay, so they use the water to turn a magnet, which is going to generate power. Okay, now we can't really control the speed of water. Okay, it really only goes as, you know, we can slow it down, but we can't really speed it up. But what we can do is, what if we add another loop here? Okay, you should see that there is more current that's being generated because we've got these 2 loops. What if we add another loop? Okay, again, you should see that there's more current with the more loops. And last but not least, what if we make this even bigger? Oh my goodness! Okay, look at all of the electricity that's being generated through this power plant. Pretty neat, huh? All right, so I want to show you some more things, and I will do that in just a second.